How's it going, guys? Today in this video, we're going to be working on day 2 of inverse functions. Find the inverse of a linear function. I believe we talked about this a little bit at the end of the previous video of finding your inverse function because it was on the homework for that day, but it wasn't covered in the notes. Anyway, these are the official steps from the textbook of how to find the inverse function. So first thing we do, substitute y for f of x. Solve for x in terms of y, and then we change x and y, and then we replace that y with the f inverse of x. In the previous video, usually I switch 2 and 3. I like to switch x and y and solve for y rather than solving for x and then switching x for y. It doesn't really matter. Either way works. That's how I was taught. Change x and y first and then solve for y. It doesn't really matter. Steps 2 and 3 are interchangeable. So either way works. But today in this video, we're going to go with how the textbook teaches it to us. So for problem B here, we have f of x equals 2x minus 2. So very first step, change f of x for y. So y equals 2x minus 2. And then we're going to solve for x. So add 2 to both sides. Y plus 2 equals 2x. Then we divide by 2. To get y plus 2 all over 2 equals x. And the last thing we're going to do is change the x and the y to get y equals x plus 2 over 2. There's no real math in between these two steps. We're just changing where x and y are. And the very last thing we need to do is just make f inverse of x equal x plus 2. Change y into f inverse of x just so we can give it the correct notation. It's the same thing. It's not really anything changing between these two steps. We're just kind of giving it the proper notation. That's all we're really doing. All right. So what we're going to do now is I'm actually going to change this f inverse of x equal x plus 2 over 2. I'm actually going to change that into a form of mx plus b. And the reason I'm going to do that is because we're asked to graph this function. All right. I do want to say one thing, that this right here is a correct inverse. So if we ever ask you to give us the inverse function, you just give us this right here. You're done. That's correct. But because we're asked to actually graph the inverse and the function itself, I'm going to go one step further to make this into mx plus b form, write the slope of a line, so I can graph it much easier. So f inverse of x equals x plus 2. And what I'm going to do is I'm going to take this number right here in the bottom, and I'm going to distribute it to each term on the top, right? So I'm going to change this into x over 2 plus 2 over 2, right? Because if I add x over 2 plus 2 over 2, I get the x plus 2 over 2 I happen to be doing. They have the same denominator, so I just add the numerator, I add the tops, I get that x plus 2 over 2. So I'm just breaking it apart, because when I break it apart, I can rewrite this now. X over 2, or x divided by 2, is the same thing as 1/2 x. And 2 over 2 is just 1. So I get this equation right here. So I can say my f inverse of x will also equal 1/2 x plus 1. And this equation right here is the exact same one that we have over here that we first got. The only difference is this new equation we have right here. It's just much easier to graph, right? With the x plus 2 over 2, I wouldn't really know how to graph that equation, but with 1/2 x plus 1, I can work with that. I know how to graph it. So I have my f inverse function now, and what I want to do is I want to verify that it's actually the inverse. And we can do that with something called composition. That's these two equations right there. Right? I'm basically plugging in the inverse into the function and the function into the inverse and making sure they both equal x. And that will tell me that my inverse is actually inverse. So f inverse of x equals 1/2 of x plus 1. And my original f of x, we said that was 2x minus 2. So let's rewrite this down here. So I don't have to keep going back up. So f of x equals 2x minus 2, and f inverse of x is 1/2 x plus 1. So what I'm going to do now is I need to verify those two compositions right there. So I need to make sure, let's actually make this in red. that the f inverse function of f of x, I need this to equal x, and I also need f of the inverse of x to equal x. So this looks pretty weird. I know that. It looks pretty weird. It's going to be a little weird. This is something you need to actually do yourself and practice to get better at. All right? So what I'm going to do here is that is f inverse of f of x. So my f of x formula right here, we said that equals 2x minus 2. So I can rewrite this right here as f inverse of 2x minus 2. Right? F of x equals 2x minus 2. So I can replace f of x with 2x minus 2 since they're the exact same thing. So I should make this in red, and that equals x. So what I'm going to do now is that, what this is saying that I have this inverse function in terms of 2x minus 2. I have this inverse function right here of 1/2 x plus 1, but I want this in terms of 2x minus 2. Or in other words, I'm going to take this x that's inside the parentheses and right inside the formula and replace it with 2x minus 2. So I get this 1/2. That's from right here, that 1/2. And instead of an x, I'm using my 2x minus 2 inside the parentheses. 2x minus 2. And I still have this plus 1 at the end there that I cannot forget about, or the answer is going to be wrong. So I took this inverse function, the f on the outside, I took it, and I replaced the x in it with what's inside the parentheses right here. All right? So now that I set this up, all I need to do now is solve it out. So I'm going to distribute that 1/2 to 2x and minus 2. So 1/2 times 2x is a positive x. 1/2 times negative 2 is negative 1. All that plus 1. And I'm hoping that equals x. And it does. Negative 1 plus 1 is 0. So I'm left with x equals x. And I'm good to go. All right, so that's half of checking my composition, half of checking my inverse is actually my inverse. So now I'm going to work on the second half, right? So in the second half, I have this right here, and I need to work on that. So what I have is I have the term f in terms of the inverse of x. So the inverse of x, we solve for it to be 1/2 x plus 1. And since f inverse of x equals 1/2 of x plus 1, I can just rewrite it like this. It's the same exact thing. The inverse of x equals 1/2 of x plus 1. So now what this is saying is I have this function f, which is right here, my original equation, and I want to change the x's inside of it to what's inside the parentheses. So I get 2 multiplied by my x value, which is now going to be 1/2 x plus 1, right? The coefficient of 2, the coefficient 2 of x, so 1/2 x plus 1. Right, I replaced the x right here in this equation with what's inside the parentheses. And all that minus 2, I cannot forget about that minus 2, that all equals x. All right, so now I'm just going to distribute out this 2. So 2 times 1/2 x will just be x. 2 times 1 is 2. So plus 2 minus 2 equals x. These cancel out. X equals x. Exactly what we wanted, exactly what we got on both sides. So I just confirmed that the inverse that we found is actually our inverse and is correct. All right, so I understand that this looks complicated, it looks hard. So what I would recommend you guys do is that you saw me work it, you saw me do this exact problem. I would pause the video and rework this problem on your own, get a feel of how to actually do this problem. And then once you're done with doing that, work on the next problem, problem 5. It's the same exact process. And I'll post the answer in a bit, and I'll walk you through it to see exactly what I did. All right. So this is problem 5. So I'm going to walk you through this really quickly. So to solve my inverse, we change the f of x to y. Then we solve for x. So I get this x equals y minus 3 all over negative 2. I change the x's and the y to get y equals x minus 3 all over negative 2. So my inverse right here is correct. f inverse of x equals x minus 3 all over negative 2. If I ask you to solve for an inverse on a test, you can stop right here where it's boxed and you'll be good. But because we're asked to graph it, which I forgot to do in the previous problem, we'll go back to that and we'll do that as well. We're going to change the form of it to make it in a easier form for us to graph. So I work this out. It's just all the math right here. Distribute the negative 2 to the x and to the negative 3. And this negative right here is what goes in the middle. So x minus the 3 all over the negative 2. You work that out. You end up getting f inverse of x equals negative 1/2 x plus 3 over 2. Okay? And then down here, all this work right here is my composition. Verifying the inverse is actually the inverse. If you got your x to equal x on both sides, you're done. You do not need to double check your work, because if you got x to equal x on both sides, that means you did right, you did everything right. This is a way of verifying that your work is right. So if you got x equals x on both sides, there's no need to go over this, you got it. All right, but if not, look what I did here, double check your work, see what I did differently, rewatch my example of the previous problem to understand exactly what I'm doing. All right, but for now, I'm going to go back here and we're going to graph this problem right here. So I'm going to graph the f of x function first. I'm going to do that in blue. That's 2x minus 2. So that means I have a y-intercept at negative 2. So that's 0, negative 2. I have a point, and then I have a slope of 2. So let's go up 2, right 1. And then go down 2, left 1. So I cannot draw straight lines, but more or less what you should get is like that. There you go. Something like that. All right? That's my f of x now. All right? And now for my f inverse, I'm going to use red. And if we go down to our f inverse function down here, where we solved it to be f inverse of x to be 1/2 x plus 1, this is why I changed the form. Because trying to graph x plus 2 over 2 that I have right here, trying to graph that's going to be a hassle. It's going to be hard. I'm going to be plugging in points and going from there. So what I'm going to do instead is I just change the form. F inverse of x equals 1/2 x plus 1. This is going to be easier. This is going to be easy to graph. I have a y-intercept at 1, and then I have a slope of 1/2. So up 1, right 2. So that's why I changed the form. It's still the exact same inverse function. I just changed the form to be able to graph it easier. All right. So that's what my two functions are going to look like. So I'm actually going to label it here, f inverse of x. And the blue one right here is f of x. So something to pay attention to is that each of these pairs of points are actually equal distance away from that y equals x line. They're equal distance. They're just as far away from that line than the other point is. And that's what it needs to be reflected over that y equals x line. There's going to be just as far away from that y equals x line as each other. It's that line cuts them right through the middle, basically. All right. So I'm not going to drag this video out any longer than this. Hopefully this video is helpful, guys. I know this stuff is confusing. Watch it, do examples, do the homework, look at the homework key that will be on Canvas. And the more you practice this, the less confusing you'll get, because the more you're used to just where everything's supposed to go. All right. So anyway, hopefully this helps. Have a nice day.